Hello everyone, welcome to Top Scholars, the Smart Learning app. The topic at hand is carbon and its compounds. So in this chapter, there are different kinds of reactions, that is oxidation, substitution, we have combustion and oxidation. Before these reactions, you also deal with the nomenclature of carbon compounds, in which we have the parent compound's name and then how the functional group's name are being added to that compound's name. Further, you deal with the different properties of two main compounds, that is ethanol and ethanoic acid. Lastly, we have the soaps and detergents topic. So in this session, we will try to revise the chapter using the questions that we have brought for you. So let's begin. Here is the question for 1 mark. It states, which of the following are alkenes? Alright, the question is asking you about alkenes. That means in carbon compounds, we start with the classification, that is carbon compounds can be classified as alkane, alkenes or alkynes, right? Let's first have the question. The entries given to us are CH4, C2H4, C2H6, C3H4 and C3H6. In here friends, you need to remember the general formula or general representation of these carbon compounds. Say for example, I am talking about the alkanes, alright? Alkanes are the saturated carbon compounds. What do you mean by saturated? That means they are only having single bonds between the carbon atoms. Then we have something called as unsaturated carbon compounds, right? In this, we will be having more than one bond in between the carbon atoms. Those bonds can be double bond or it can be triple bond as well. So in this, we learn about the alkenes and the alkynes, okay? In here, obviously, alkenes are having double bond and alkynes are having triple bonds. Alright, this is the classification of hydrocarbons that we do whenever we are talking about carbon compounds. In here, we have general representation for each of this group. For alkane, we have the general representation of CnH2n plus 2. Okay. For alkenes, we have CnH2n. For alkynes, we have the general formula, that is CnH2n minus 2. Okay. So, following this formula, we will try to see which of these compounds fall into or follow the general representation for alkenes. Okay. So, say for example, I am having only one over here. That means I will have C1 and H2. Okay. That means this number is twice of this number. 1 into 2 will give us 2. So, we will find out which of these numbers are in the multiplication of 2 value. Okay. 1 times 4 will be 4. So, this is not an alkene. Okay. Over here, we have 2 and 4. 2 times 2 is 4. Okay. So, this will be our alkene. Then we have 2 times 3, which is 6. Okay. So, again, not 2 times, hence we will discard this as well. Okay. So, these 2 are discarded. Then we have C3H4. Again, no multiple itself. So, we will eliminate this one as well. Over here, 3 times 2 is 6. So, we will take it as alkenes as well. So, we have solved this question just by knowing this general formula, that is CnH2n. Alright. So, coming to the solution part of this question, herein we have C2H4 that we have already chosen and C3H6 as per our discussion as alkenes. Okay. Mentioning these things will enable you to score that 1 mark. Now, let us have some more information about alkene. It is an unsaturated hydrocarbon, okay, as per our discussion, and it has C double bond C bonds. And it has a general formula of CnH2n, where what is this N? This N is the number of carbon atoms. So, in here we have 2 carbon atoms, in here we have 3 carbon atoms and so on and so forth. Okay. So, by knowing the general formula, you can attempt such questions. In the exam, it may appear to you that some entries are given and they are asking you which of these are alkyne, which of these are alkane. Then you need to just substitute these numbers and try to fit in the general representation or general formula for alkane, alkene and alkyne. In whichever it will fit, then that molecule is actually coming into that group. Alright. You can also go for the diagram, but this is a more simpler way to approach this question and it will save your time as well. Also, you will already be knowing some compounds, like this is methane, this is saturated one, you know, so you can easily eliminate this one. Okay. So, practice will make you very much perfect for attempting such question, you will be very efficient. Alright. Here is the question. It says that write the chemical equation for the reaction that takes place when ethanol is mixed with ethanoic acid. Okay. So the reactants are provided to you, that is ethanol and ethanoic acid, and this reaction is done in presence of an acid. Mention the name of this reaction. This is the question that is being asked for 2 marks. Let us go for ethanol and ethanoic acid. Over here you will see this is the ethanoic acid, right? CH3C, 2 carbon, that's why we are using the parent word, that is eth. Okay, and this carboxylic acid will give you the oic acid. If I have to find out the IUPAC name, it will be ethanoic acid. Okay, that is being given in your question. A common name will be acetic acid. This is reacted with alcohol, that is ethyl alcohol, a common name, or ethanol, IUPAC name. Here again 2 carbon atoms, so ethane, H is replaced by OH, hence ethanol. Alright. This is reactant in presence of concentrated H2SO4. Concentrated sulfuric acid is being used as an acid that was mentioned in your question. The products are CH3COO, C2H5 plus H2O. So water is being produced, and over here friends, the functional group is C double bond O, and here we have O. Okay. Then over here we have C2H5, and over here I have CH3. So this is the compound that is being produced, and this compound is having an ester group. This group C double bond O, C, is known as ester group. Okay. So this reaction is termed as, obviously as the name suggests, esterification is done. Hence this reaction is called as esterification. Let us have the name over here. This is ethanoic acid, this is ethanol, and this is ethyl acetate. Okay. So in this name, let us have the bifurcation. This is the ethyl part and this is the acetate part, because it was derived from acetic acid. Okay, hence we have a common name of ethyl acetate. Going ahead friends, this reaction is termed as esterification reaction because there is an introduction of ester functional group. Alright. So dealing with these kind of reactions is very common to you since you have already studied the chapter. While revising as well, you need to have the structure, the common name, the IUPAC name, and how the reaction proceeds, what are the catalysts that are being present. And one more thing is the name of the reactions. Alright. Here is the question for 3 marks. It states that explain the mechanism of the cleaning action of soaps. So you might be already knowing that we use soaps to clean our clothes, to wash ourselves, to take the bath. Okay. Why are we using the soap? Why not just water? Because that soap will help us to clean ourselves. It will help to remove the dirts. Alright. The dirt or oily things that are present on our clothes, on our body, will be removed when we have the rubbing action of soaps. So how is that happening? That is asked in this question. Let us go for the solution part. Over here, a soap molecule consists of 2 parts. That is for sure, you should be knowing that. If I draw this molecule here like this, okay, this is a soap molecule. There are 2 parts in it. First part is head and another part is tail. Please remember this much at least. Okay. Now we will go into the detail of this molecule. This long chain is having hydrocarbon nature. Okay, that means HC, HC, CH, CH, CH will be repeating over here. So this is a long tail that is being formed by CH repeating groups. Hence we are saying that this long chain is hydrocarbon tail. And then one more thing, since it is having carbon and hydrogen, so what do you think? This structure will be soluble in water or not? Yes, obviously it will not be soluble in water. Hence we are saying that it is hydrophobic in nature. Okay, it is having a phobia. It doesn't like water. It doesn't dissolve in water. So this tail is the hydrophobic tail and it is made up of hydrocarbon chain. Okay. What about this head? This is hydrophilic because there is some charge present to it, and if you can charge something, then it will be dissolving in water. Okay. So let us write it down over here. Head is hydrophilic in nature. Okay, present over there. Now talking about this soap and what are we doing actually when we have some cleaning action. When this soap is added to an oily or greasy part of the cloth, what will happen? The hydrocarbon part of the soap dissolves in oil, keeping the head away from the oil. Why so? Because like dissolves like. So this oil is also having hydrocarbon nature, and over here we also have the hydrocarbon nature of the tail. So if I say this is the oil droplet that is present on my cloth and then I am using the soap, what will happen is this soap molecule will orient itself like this. Okay. Okay, so this is the orientation of this soap molecule around this oil droplet that is being present. So the hydrocarbon part of the soap dissolves in oil and keeps the head away from the oil. Okay, why so? Because these all things are hydrophobic and this one is hydrophilic. So I am also adding water while I am washing. So hence this is forming the outer edge of this micelle. Okay, this is the micelle formation. Should also know that, because if I will have an association of the soap molecule like this only, all the soap molecule will have the hydrophobic chains aligned and then the hydrophilic head will be aligning at the outer side. Alright, that is the micellar formation. Going ahead, big molecules of oil and soap will break now because you are also doing the rubbing action while you are washing something. So they will be breaking down into small emulsified oil droplets in water, which will be washed away by the stream of the water. Okay, so this is how we actually wash our clothes and dirt is being washed off. Alright. The soap molecules which form micelles assist in dissolving the dirt in water, thus we can wash our clothes. Okay, so this is the whole mechanism for the cleansing action that we see in the soap. Writing this much, and if you were able, you can draw this simple diagram as well, and that is good to go for you to gain your 3 marks if this question comes in your exam. Going ahead, this question is asking you what makes the water hard. So this question is coming for 2 marks. You might have seen, friends, this very commonly that when we take a bath and we are using the soap, there is lather formation because of that soap. We do the rubbing and then soap lather is formed. But sometimes if the water quality is something different, okay, we have borewell water or we have a different kind of water coming from another tap, okay. In that water, when you will use that water for your bathing purposes, then you will see that the lather is not formed properly, okay. And you might have heard that that water is hard water, okay, and the regular water that we use for drinking purpose and all of those things is soft water. Here the question is, what makes the water hard? What is the constituent of that hard water that makes it different from the soft water? So basically, friends, more salts are present in that kind of water. What kind of salts? We will see in the solution part. So over here, hard water contains soluble salts of calcium and magnesium. Okay. The water is homogeneous. We cannot see any kind of salt present in that, right? But there are presence of salts of calcium and magnesium which are dissolving in that water. Because of this higher amount of salt, we are saying that this water is hard. These magnesium and calcium salts are interfering with the lather formation. Hence, this water will not give you lather formation when you are using this water for your bathing purposes. Okay, going ahead, due to the precipitation of the insoluble soap. Okay, this soap was soluble in the soft water, but over here there is precipitation of the soap. Hard water does not give you lather with soap. So how can we form lather in this hard water? Yes, we will be using detergents. This thing you might have already studied in your chapter. Okay, going ahead. The cause of hardness of water is due to the presence of bicarbonates, sulfates and chlorides of calcium and magnesium present. Alright. So earlier we said that salts of calcium and magnesium are present. But what kind of salts? We can name it also. Yes, these are bicarbonates, sulfates and chlorides of calcium and magnesium. Because of the presence of all of these things, we are saying that this particular water is hard in nature. Okay, it is not soft water. So friends, this is also a detail that is covered in your chapter which shows you why we have soft and hard water and what are the constituents that are different in hard and soft water. Okay, in the exam you might get a question, how is hard water different from soft water? Okay, again the contents will be same. You just have to frame your answer and fit that question. Okay, here is the question for 1 mark. It is a MCQ. It says butanone is 4-carbon compound with the functional group. That means you are just being asked the functional group of this compound. This is a very simple question. I am almost sure you might have already answered this question, but we will have the detailed explanation as well. The trick to be noticing over here is that over here in this name we have "-one". Okay, this is the suffix that comes at the end of the word, prefix that comes at the beginning of the word. Okay, so if I have chlorobutane, chloro is the prefix, but here "-one" is the suffix. You need to be clear on these simple terminologies when you are dealing with the nomenclature of carbon compounds or with nomenclature of any compound. Okay. So this one you can relate it with this ketones ONE, right? None of the other options are having same suffix. So we can relate that, okay, the correct answer might be ketone. Over here, what is the suffix that we add for aldehyde? It is Al, okay. So if I have ethane and then I am having the aldehyde formation of that ethane, I can call it as ethanol. Alright, Al is the suffix for aldehyde. For carboxylic acid, we add the suffix of oic acid. Okay, so again taking ethane, we will have ethanoic acid. Okay, as we had in a question just before in our session. For alcohol, we will be adding OL. Okay, so if I have ethane, then ethanol. This OL will signify that the compound is alcohol. Alright, this also we have dealt in our previous question. So basically friends, for ketone we will be having butanone, okay, methanol or propanol. All this ONE in the suffix will give you an idea that it is a ketone indeed. Alright, let's go for the solution part over here. It says that butanone is a 4-carbon compound because of this parent name butane. We have methane which is having 1 carbon. Then we have ethane, 2 carbon atoms, propane, 3 carbon atoms, butane, 4 carbon atoms. Then we have pentane, 5 carbon atoms, hexane, 6 carbon atoms. So you need to know this parent compound and how much is the number of carbon atoms that are present. Okay. After that we can add this functional group and we will name it very simply. So if I am saying that here is the butane, okay, with the 4 carbon in its parent skeleton. So here if I am saying that this is butane with the 4 carbon in its skeleton, then for it being a ketone, I need to have a double bond O, this functional group, okay. And please remember, this ketone group will not be coming towards the end, because if you put it over here, then you need to add 1 hydrogen to complete the valency of the carbon, and then it will become an aldehyde instead of a ketone, because in aldehyde we have this group C double bond O H, okay, and this will be binding to the rest of the molecule, okay. So that one is an aldehyde. To distinguish it from a ketone, we have the C double bond O bond in between the molecule, okay. So coming back to the part that we were studying in the solution, it says that butanone is a 4-carbon compound with the functional group of ketone, right. Going ahead, a ketone is a functional group having a carbon atom attached to an oxygen atom, okay, but this is done with a double bond as we have just shown you over there. And the other 2 valencies of carbon is satisfied by 2 alkyl groups. This is very much important because as we said, if we satisfy any of the valency with hydrogen, it will become another functional group. So the rest of the valencies should also be satisfied by another alkyl groups, alright, for a molecule to be a ketone. Going ahead, all the members of the ketone family are represented by the suffix -one. Hence, we have identified and correlated. This is having -one, this is having -one. So, obviously, this compound is a ketone. Okay. Lastly, since butanone has the suffix -one at the end, therefore, it belongs to the ketone group. So, friends, in this question, we have talked about different functional groups. So, if I talk about homologous series, this is the series of carboxylic acid, this is of aldehydes, this is of ketones, this is of alcohols. They will be having similar features to each other, okay. In this question, we have learnt about the parent compound, how many carbon atoms can be present when we are talking about methane, ethane or propane or hexane or butane, alright. And then we have learnt about the prefix and suffix, okay. And then finally, how ketone is different from a aldehyde. In your examination, the question might be of butanoic acid and they will say that it is a 4-carbon compound, or they might also not say it and they will ask you what is the functional group in that, and you will be able to answer that question because you have watched this video which covered all the related details. Now, let us move on to the next question. Here is the question asked for 1 mark. Again, it is a MCQ. The question says, the reaction between CH4, okay, we have dealt with that CH4, it was methane, a saturated compound, okay. Try to always connect the links so that your revision will be foolproof. Going ahead, the reaction between CH4 and chlorine in presence of sunlight is an example of. In the beginning of our session, we told you that there are different kinds of reactions which are present in this chapter, and all of those reactions are important, whether you are talking about oxidation, combustion, substitution or addition. because such kind of questions are already being asked in your question and there is high probability that such question will their way in your upcoming examination. Alright, so coming back to the question, we have different options: substitution, combination, addition and decomposition. Okay, decomposition reaction we have covered in other sessions of our series, in which the reactants seem to be decomposed. If we have one reactant, it will be decomposed into more than one product and then we will say that decomposition has occurred. Okay, now coming back over here, methane is reacting with chlorine in presence of sunlight. So you might have seen a reaction with UV on the arrow side. Okay, this reaction of methane reacting with chlorine in presence of sunlight is an example of substitution reaction. How? We will see. First of all, let us have the reactant for this. Okay, so here we have the methane. Methane is written as CH3H. It is CH4 only, but we have separated and we have written one H separately. So over here, this Cl2 is also broken down, Cl, and there is a covalent bond obviously that you might already be familiar with this thing. Why is a covalent bond present over here? So this Cl and this Cl will give you Cl2 only. We have written it separately. That's it. Okay, no other thing is written over here. Then we have UV light, and now what will be happening is these things will form one product and this thing will form another product. Okay, so we have CH3Cl, that is methyl for the methyl group, and chloride for the Cl atom, and along with it we have HCl production. Okay, so here we have substituted. In the presence of this H, we have the introduction of this Cl. So Cl is substituting the H atom. Hence, we have the formation of methyl chloride. Now, let's go for the solution part. The reaction between CH4 and chlorine in presence of sunlight is an example of substitution reaction. Methane reacts with chlorine in the presence of sunlight, and it is also an example of halogenation. Why so? Because friends, in the group 17 of your periodic table, halogens are present. We have chlorine, bromine, iodine, right? Fluorine is also there. So all of these things are halogens, and if you add these things to hydrocarbons, then the reaction is called as halogenation. This is also something that you already might have known. So this reaction is substitution, and this is also an example of halogenation. Now say for example, instead of this decomposition reaction, I have given you an entry of halogenation. Then you will choose the option which has both substitution as well as halogenation together. Alright, just ticking on one thing will not lead to you gaining the marks. Okay, hence again you should be observant on what the question is asking you and what are the options that are provided to you. Coming over here friends, in the Cl2 molecule, we talked about how there is a covalent bond present in it. In the beginning of your chapter, you are dealing with why carbon is not either donating or losing the 4 electrons that are present in its valence shell. You need to understand that part and then you can extrapolate that knowledge to the Cl as well. Why are covalent bonds and covalent compounds formed in our environment? Okay, we will be dealing with it as well in the upcoming time. Alright. Here is the question coming up for 2 marks. It states that an organic compound A with molecular formula C2H4O2. Now this compound is given to you in empirical form. You cannot identify which is the functional group by just looking at this formula, right? So let us have the question. An organic compound A with molecular formula C2H4O2 turns blue litmus red and gives brisk effervescence with sodium hydrogen carbonate. Identify the compound A. Okay, that is the question that is being asked. So in here friends, there is a hint that is provided to you. First of all, whichever the compound that they are talking about is turning blue litmus red. That means, yes, it is acidic in nature and it is an organic compound. That means it is organic acid. Okay, that much hint we can pick up from over here. And then we have this formula. From this formula, we can take that in the parent compound there are 2 carbon present. Okay, and it needs to be acid as well. Yes, I think you might be getting to the correct answer from all of these things that we have highlighted just now. And here we have some more details. Let us start with the solution part to identify the compound A. As we just said, given that A turns blue litmus red, so A is acidic in nature. Then we have brisk effervescence with sodium bicarbonate or sodium hydrogen carbonate. Both the names can be used. So it indicates that carbon dioxide is one of the products. Okay, let us have it over here. The reaction is present over here. So this is the sodium hydrogen carbonate or sodium bicarbonate that we were saying. Now over here, this brisk effervescence led to the conclusion that CO2 gases evolved. Okay, therefore we are having brisk effervescence, bubbles are coming out because of this gas. Now coming back, this is C2, okay, so we have two C groups. So we have two C atoms, one is over here and one is over here, and it is acid, so we will have OOH, okay, it is organic acid, hence we can have carboxylic acid group, and then we will just fulfill the valency of this carbon and we are good to go with the compound's chemical formula. Okay, it is CH3COOH, it is acetic acid. Okay, so this acetic acid is reacting with sodium hydrogen carbonate, and what we are forming? We are having the displacement of this H. Okay, this H plus will be going out, CH3OO minus will be combining with this Na plus, and this will also go as negative ion. Okay, so this Na will combine over here and we have the formation of CH3COONA along with water and along with carbon dioxide. Let us name each and everything over here. This is the reactant part and this is the product part. This is the acetic acid. Here we have sodium hydrogen carbonate. This is sodium acetate, okay, sodium, and the salt of acetic acid is it is acetate then. Okay, so this is sodium acetate. Here we have water molecule and this is carbon dioxide. Alright. So in here, just by the information that is given to us, we could have guessed the answer correctly. Okay, this is C24H2, 2 carbon is required. It is an organic compound because of the involvement of carbon and hydrogen atoms. Okay, and then it is turning blue litmus red. That means there is an acid present. Okay, all of these things will lead to the identification of the compound that is being asked to you. Alright, so this is all good to go for 2 marks that you are achieving. Here is the question for 2 marks again. It says, write the name and formula of the second member of the series of carbon compounds whose general formula is CnH2n. Now, try to remember what we have just talked in the beginning of this session and tell me what is the name of this compound which is having the general formula of CnH2n. Say for example, I have N substitution as 2, then 2 times 2 will be 4, right? So this molecule C2H4 is alkane, alkene or alkyne. Yes, you will be very easily confirming that this compound is an alkene. Why? Because of this general representation, right? So let's come back to the question again. Write the name and formula of the second member of the series of carbon compounds whose formula is this. That means we need to have the name and formula of second member of the alkene series. Alright, let us have the solution part. Over here, the general formula is CnH2n, indicating that this one is a alkene. That means there is double bond present, right? And this is unsaturated as well. That is clear to you. Going ahead for the first member, then only we will go for the second member. You will be having first step, then you will be having the second step. Let us go over here. For the first member, we need to have N is equal to 2 for first member. Right here, we have written C2H4. That is only written, right? So, C2H4 can be represented as C, double bond C, and then rest of the valencies will be filled up by hydrogen. This is the first member. If you try to name it, what is the name of this compound? Yes, it is ethene, alright. This part is the parent name and this part is the functional group, that is double bond that is present in our molecule. Let's go for the second member that is being asked to us. Second member is having N equal to 3, therefore Cn, N is replaced by 3, and here 2N, that means 2 times 3, that will be 6. So we have C3H6 molecule and it is written over here, 3 carbon atoms you can see, 1 double bond will be there, okay, and then we have filled up rest of the valencies with hydrogen, and this is the second member. Now here, if I ask you what is the name of this compound, such questions also come, right? They will give you the structure and they will ask what is the IUPAC name, or they will give you the name and they will tell you to draw the structure. Okay, such thing can also happen. So you should be handy in dealing with all types of questions. Okay. So over here we have CCC, 3 carbon atoms. That means the parent compound will have the name of prop. Okay, propane, 3 carbon, and over here we have the double bond. So prop1ene, or simply you can write propene as well. That is also good to go. So friends, doing all of these things was 1 mark for this and 1 mark for this. You will be easily able to gain your 2 marks for such questions if they appear in your exam. Or Just try to extrapolate and apply this knowledge in questions that are coming in your actual examinations. Okay. Here is the question asked for 1 mark. The question says, what is the difference in the molecular formula of any two consecutive members of a homologous series of organic compounds? Now I need to ask you, what do you understand by the term homologous series? Okay. Here friends, I'll give you a hint, and that is the functional group in homologous series is same. So if I say alkane is one homologous series, then what is the similarity? Yes, each and every carbon will be having single bond only. Okay. There will be no double bond or triple bond. That will be consisting of one homologous series. It's almost as equal to your class divisions. You have 8th, you have 9th. So in 8th standard, all the students will be having the 8th standard level information in your textbooks and everything. And a 10th standard student will have different syllabus. Okay, they are grouped together, these are grouped together. That is the concept of homologous series. Now we can say that in one homologous series, the functional group is same. So now if I take an example of alkenes as one homologous series, then we will have the individual members starting from ethene, then we have propene, then we have butene, pentene, and so on and so forth. If I take about alkynes, it will be ethyne, propyne, butane, pentyne, etc. and etc. Okay. So that is the major understanding behind homologous series that you should be having. Over here we are asked what is the difference in the molecular formula of any two consecutive members. Consecutive members means one is followed by the other. These are consecutive, not this one and about this one. Okay, that is having one more member in between. So these two things are not consecutive. One followed by another will be forming the consecutive pair. Okay, again a general understanding of the terminologies. Coming back to the question, what is the difference between these two consecutive members in a homologous series of organic compounds? So friends, the correct answer is CH2 unit. That is the difference. Over here you will see the molecular formula of two consecutive members of the homologous series of an organic compound differs by CH2 unit. Why is this so? Because the functional group is same only and you are going one by one. Right? So if I have ethene over here, I will have propane over here. And if you will see, one carbon is increased and two hydrogen is increased in distinguishing point of that propyne and ethine or propene or ethene. Okay. You can apply this knowledge. You can check for different homologous series. You will always find that the consecutive members are differing by CH2 unit. Over here, you are given the detail about homologous series. It is defined as the group of organic compounds containing particular functional groups. Okay, so as I have mentioned, single bond, then we will have one homologous series, double bond, another homologous series, right? Over here, to gain this 1 mark, you need to have this information, okay? You may not describe what is this homologous series, but you need to mention this detail, okay? This we have included for you to have a correct understanding, all right? Here is the question coming up for 3 marks. The question says, an organic compound A of molecular formula C2H6O. This is the empirical formula given to you. That is the form which is provided, okay? You cannot identify what is the functional group just by looking at this, okay? Chemical formula will give you an identity of what is the functional group. So over here the question says an organic compound A of molecular formula C2H6O on oxidation with alkaline KMNO4 solution. Okay, this is oxidation reaction going on. Gives an acid B with the same number of carbon atoms. Now compound A when reacts with sodium metal liberates hydrogen gas. Alright. Again a hint is given to you that hydrogen gas is being liberated. Name the compound A and B, write the chemical equation for all of these reactions that is happening. Okay. So in this reaction, we are starting with ethanol. Why so? Because over here we were provided with the empirical formula of C2H6O. Say for example, I am having 2 carbon over here and then I need to have this hydrogen. If I add 3 hydrogen over here, 3 hydrogen over here and 1 carbon single bond will be present. So all the valency of this molecule will be satisfied. So how will I add this O in it? Okay. Hence for adding O, I need to introduce an alcohol group to this molecule. Right. Now I am left with 5 hydrogen. Right. So let us do that. Okay. Now we can say that all the valencies are fulfilled very appropriately. Okay. So this is CC, 2 carbon, then we have H6, that means 5 from over here, 1 from over here, and oxygen is also there. Okay, so this compound is nothing but the ethanol. So this ethanol is undergoing oxidation using this alkaline KMnO4, along with which we are also supplying heat. The product we are forming is ethanoic acid, okay, CH3COOH. Common name if I ask, yes, it is acetic acid. Now, this fulfills the condition that were provided. An organic compound A of molecular formula this that we have already discussed, on oxidation with these things gives an acid B with the same number of carbon atom. If you will see, here also 2 carbons are present, here also 2 carbons are present. Okay, so we have fulfilled the first condition. Now, this compound A, when reacting with sodium metal, okay, so now we are reacting this ethanol with sodium metal. It will liberate hydrogen gas, that is for sure, okay, because alcohol is reacted with metals, so we will have the liberation of hydrogen gas. Now, the question says name the compound A and B. That means A and B we have already mentioned, okay, and then we need to write the chemical equation. For first part we have done, let us go for the second part because we never know what question will actually come in your exam, okay, so we should always touch each and every related topics, okay. So going on for the next one, ethanol is reacted with sodium metal and then we have the formation of sodium ethoxide. This thing we will also discuss in our session later. Over here, this part is for etho, this part is for eth, this O is giving you oxide part and this Na is giving you the sodium part, okay. So this ethanol reacts with sodium metal to give you sodium ethoxide with the chemical formula C2H5ONa, alright. And along with it, hydrogen gas is liberated. So this reaction is only written over here and we have discussed both the reactions that were asked to you in the question and writing all of those things, identifying that this molecule is alcohol first step and then doing the reaction for the first part and then having the reaction for the second part will fetch you 3 marks that were provided by this question. Now, having a conclusion for the question, A is ethanol as we have already mentioned, with the molecular formula C2H6OH, okay, and B is CH3COOH, which is the ethanoic acid, having carbon count 2, which is same as ethanol, okay. Here is the question asked for 3 marks. Here you are provided with reactants and we need to fill in the gaps for the products, okay. The question states complete the following reactions, as simple as that, alright, and this will give you 3 marks if you do it properly. So over here friends, there is hydrolysis going on for this compound, okay, and similarly you have different things combining with the organic compounds that are present over here. Let us deal with each of these things separately in our solution part. We will have the very first reaction, that is CH3COOC2H reacting with water and it is giving you CH3COOH. What is this compound? Yes, you can name it. It is acetic acid. And along with it, we have the formation of an alcohol, that is C2H5OH. Okay. So over here, friends, what do you think is the nature of this compound? Yes, it is an ester. Ester meaning it is having C double bond O group. Okay. This group is present in this molecule. Now, if you try to name this ester, then it will be methyl ethyl ester, okay, because this is methyl group, this is ethyl group and there will be ester word because this functional group is of ester. Now, I need to ask you whether you will write methyl first or ethyl first in this name, okay, that is left to you to ponder upon and to find the answer. Over here friends, water is there, over here acetic acid and this is ethanol. Why so? Because 2 carbons, so the parent compound will be eth, right? ETH we will be using. And then alcohol is there, therefore we will be using ethane and then ol will be there. Okay, that is the suffix, not prefix. Okay. Now let us proceed with the second one. Second reaction is of CH3COH. This is what? Carboxylic acid, right? And carboxylic acid, I am saying that with respect to COOH. What is this called as? CH3COOH we have just saw in our first reaction, that is acetic acid, or following IUPAC name it will be ethanoic acid. Why so? Again the parent compound is eth, okay, and then for carboxylic acid the suffix we are using is oic acid, so it will become ethanoic acid, okay. Coming back to the reaction, this ethanoic acid is reacted with sodium bicarbonate or sodium hydrogen carbonate, okay. And over here, this reaction we have already discussed, this H will be going out, this Na plus will be substituting the H present in the acetic acid, and hence we will be having the formation of CH3COONA, which is nothing but the sodium acetate, and along with it we have CO2 and H2O. Just now we have studied that this CO2 gives us brisk effervescence. Alright, please try to link all of those things and have a clear and big picture of the concepts that you are trying to understand or revise. Okay, now let us go for the third reaction. It says that CH3COOH is reacting with Ca2H5OH. Okay, that means this is a carboxylic acid, which we already know now is acetic acid, and over here we have alcohol, which is ethanol. Okay, and these are reacting to produce what? They are again producing the ester. If you will see, the reactants of this reaction is the product of this third reaction. Okay, so you can always easily link some reactions in your chapter. Okay, so going ahead, this is an ester, again methyl-ethyl ester, which will come first, that is left for you. And then we have the water formation. Going ahead for the fourth one, that is D, C2H5OH is reacting with Na. Again, this Na will displace this H and we will have the formation of C2H5ONa. Okay, and this hydrogen gas is liberated. For balancing the equation, we have added this 2. You can check they are balanced. Then we will go for the E part. It says CH3COOH is reacting with NaOH. NaOH is a strong base, that is understood to you. And now again this Na will displace this H and it will form CH3COONa. Okay. Now over here friends, here the functional group is ONA. So there is some different name for this thing. And over here we have OONA. So we will write that it is sodium acetate. And along with it we have water formation. In the D part friends, this name is sodium eth, that is for C2H5 oxide because of the presence of oxygen. Okay, so this is sodium ethoxide, which is the product in your fourth reaction. Writing all of these things will fetch you 3 marks for sure. So friends, where do you think is this question coming from? Yes, this question is coming from the section of your chapter which covers the properties and chemical reactions of ethanol and ethanoic acid. Right? You have some reactions about these compounds and this question is straight away coming from there. If you can link it, very good, you will be able to grasp this easily given marks to you. Here is the question for 2 marks. It says to give reason why element carbon forms compounds mainly by covalent bonding. This thing we were talking just few minutes earlier, right? So why is this carbon only forming covalent bond? Why not ionic bond? So friends, if you remember, I talk about NaCl, this is the compound which is ionic, okay, ionic compound is there. Herein, ions are produced upon hydrolysis, so Na plus and Cl minus is produced, okay. And sodium's electronic configuration is 281, so it will tend to lose that 1 electron. It is metal, so it has a tendency of losing the electrons. Then talking about the Cl minus, it is having the electronic configuration of 287, okay, so it will have a tendency to gain 1 electron to acquire a stable electronic configuration, and it is a non-metal. Non-metals generally acquire electrons, they have that tendency. So all of those things will be done only to gain a stable electronic configuration resembling the noble metals electronic configuration, right? So the atomic number of carbon atom is 6, okay, this is the atomic number, we will write it over here. That means 6 electrons are present and 6 protons are present, that you can already easily infer from this information of what is the atomic number of the atom. Okay, now let us draw the nucleus over here. This is the first shell and this is the second shell. And I have 2 electrons in the first shell because its capacity is of 2 electrons only, K shell. Then I have remaining 4 electrons, I will place it in the next shell and this is the L shell, okay. The capacity is of 8 electrons but only 4 are present. And this is the outermost and these electrons are present for reactions and all of those things. So we will say that these are valence electrons. Now what will happen? To acquire a stable electronic configuration, this carbon atom can either donate this 4 electrons or it can accept these 4 electrons. Both options are available. But it is choosing none of these. Why is that? So friends, over here we have said that 6 protons are also available. Okay, and 6 electrons are also available for the carbon atom. Say for example, this carbon atom is donating all of these 4 electrons in its valence shell. So now it has the nucleus with 6 protons and electrons are only 2, okay, because these 4 are lost, okay. So there is a discrepancy in the energy between the nucleus and the shell. So there is a discrepancy in the energy that is present in this nucleus and the electrons that is present in the atom. Now say for example, considering another scenario in which this carbon atom is accepting 4 electrons, okay, to obtain a stable electronic configuration. Now what it is doing is, this carbon atom is acquiring 4 electrons, so the number of total electrons is now 8 plus 2, that is 10. So 10 electrons are present but protons are still 6 only in the nucleus. Again the energy discrepancy exists, okay. Hence, this carbon atom has chosen another way of forming bonds, okay. It will not only form the ionic bonds, it will go for covalent bonding, okay. Let us understand covalent bonding also with the help of methane molecule, okay. Methane CH4 we have just talked. This is the methane molecule and it is having covalent bonds in it. So, if I say, while drawing the electron dot structure, we will only be considering the electrons in valence shell now, not this one we will be considering. Say for example, this cross is representing the valence shell electrons of carbon. Carbon has the valency of 4, hence we have shown 4 electrons. Now, hydrogen is also having 1 electron, right? So, let's say this one is the hydrogen, okay. Now, if you will look over here, these electrons, these 2, are neither completely belonging to the hydrogen nor they completely belong to the carbon. They are being shared, okay. Like if you are having a roommate and you are living with him, the house does not belongs to you only and it doesn't belongs to him only, okay. It is a shared occupancy. You both are having ownership of that house. So now this carbon atom has shared these electrons. Okay, I'll draw it over here and this is the hydrogen which is the other partner, okay. Now you will see carbon as well as hydrogens have their valency fulfilled, okay. Here hydrogen is having 2 everywhere, so it has achieved its electronic configuration which is stable. For carbon also you will see 8 electrons it is having, okay. So it has also achieved a stable electronic configuration. So this is the reason why carbon forms compounds mainly by covalent bonding and not by ionic bonding. Let us now have the solution part. So, following the solution part, carbon has 4 electrons in its outermost shell and needs to gain or lose 4 electrons to attain noble gas configuration, just as we have seen. Then, losing or gaining 4 electrons is not possible due to the energy considerations, hence it shares electrons to form covalent bonds. Hence, it is opting out on the ionic bond formation. Here is the question coming for 2 marks. The question says, why butter does not decolorize bromine water whereas cooking oil does? This bromine water is Br2 water. Now, over here friends, to decolorize this bromine water, you need to have double bonds in whatever thing that you are treating with it, okay. And this only tip or hint will give you an idea why is butter not decolorizing bromine water while our cooking oil is doing that. Okay, coming back to the solution part. So, giving you a hint on this question friends, bromine water will decolorize a solvent or a solution or anything that you are treating it with if there are multiple bonds present in that thing, okay. It should have double bonds or triple bonds, then only it will decolorize. If the thing that you are treating the bromine water with is only having saturated bonds, that is single bonds, then it will not decolorize. This hint will help you to solve this question now very easily. Let us proceed with the solution part. It says that if multiple bonds are present in an unknown sample, it will decolorize the bromine water. Okay, this is the basic necessity for the decoloration of bromine water. Going ahead, cooking oil is an unsaturated fat. Okay, here itself we have answered the question. This cooking oil is unsaturated and this butter is saturated. So, butter is saturated. No multiple bonds are present, hence no decolorization of bromine water. Over here, unsaturation is present, multiple bonds are present, hence it will decolorize the bromine water. Coming to the sentence, cooking oil is an unsaturated fat. Thus, when bromine water test is performed with cooking oil, it will decolorize the bromine water. Going ahead, talking about the butter. Butter is saturated fat and hence it does not decolorize bromine water. So what is preferable to make our cooking and our food stuffs in? So friends, you should remember this bromine water test and which kind of compounds will decolorize it and which kind of compounds will not decolorize it. Alright. Here is the question for 2 marks. The question says, why ethine burns with a sooty flame? First of all friends, the very main thing is combustion can be complete or it can be partial. If there is complete combustion, no residual is left, as the name suggests, and if it is partial combustion, then the residual will be there. That residual is the sooty thing that you see. You might have cooked something or you might have seen someone cooking in your home. Sometimes your utensils become blackish from the bottom at the area in which they are with contact with the flame. Okay, why is this thing happening? Is because the flames are provided with air inlet as well. If the air inlet is proper and the air is coming during the flame formation, then there will be complete combustion, okay, with no residue. But if the air inlets are blocked with some dust particle or with some clogs, then what will happen is air introduction is prevented, it is slowed down, and hence you are having partial combustion, which is giving rise to a sooty residue, and that's why you are having the sooty flame. Okay, let us answer it over here. Unsaturated hydrocarbons such as acetylene have a high percentage of carbon. Okay, they have a higher percentage of carbon as compared to the corresponding alkanes and alkenes. Okay, so we have made a comparison between alkanes, alkenes and alkynes. Herein we are asked about an alkyne. Ethine can also be called as acetylene. Okay, both are the same thing. This is the common name and this is the IUPAC name. Okay, so they have a higher percentage. These alkynes are having higher percentage of carbon as compared to the corresponding alkanes and alkenes. Then when ethine is burned in air, it does not get completely oxidized. Okay, coming back to the square one that we have started, combustion, if it is complete, no sooty residue. If it is partial, there will be sooty residue. So herein, ethine is burned in air and it is not getting completely oxidized, thereby it is producing a sooty flame. That is the answer that will fetch you 2 marks in your exam. Here is the question asked for 1 mark. See, we have just discussed you could be given the structure of the compound and you will be asked to name it, or given the name of the compound and the structure is asked to you. So the question says, write IUPAC name of CH3CH2CH double bond CH2. I want you to pause this video and just try to name the parent compound over here. How many carbon atoms are present? Yes, they are 4 in number. So obviously we will be having bute. Okay. Now other things are other picture, we will see to it. Over here, double bond is present. So obviously in the name, we should be having ene. Okay. This ene will be coming in suffix or prefix, that is clear to you. Now I can write it as but1ene. Why so? Because we will always give less numbering to the functional group. Here the functional group is the double bond itself. So we will number it 1, 2, 3 and 4. The double bond is present between first and second carbon. So I have written but1ene. Okay, let us see the solution part if it is right or not. So the correct answer is but1ene. This is the structure that is provided to us. Here we will try to justify it. IUPAC nomenclature of organic compounds refers to the systematic approach taken for the nomenclature of organic compounds as per the recommendation of the IUPAC, that is International Union of Pure and Applied Chemistry. Okay. So this is an information that is provided to you. No need to add this thing in your exam. Okay. Only if they are asking you the full form of IUPAC, then you can answer this thing. Okay. You can utilize this part of information. So since we had the double bond, we will have the suffix ene which is being used, and it is used to describe the alkenes. What is the general formula? You try to remember it from the earlier session. Okay. And this is as per the IUPAC norms with lowest possible number to double bond as we have given to it. Functional groups should always be given the lowest possible number. And if you have different functional groups, then there is IUPAC norms for that as well, which should be given the priority and which can be used as second priority. Okay. So the correct answer for this question is but1ene. Write this thing and you will be able to gain your 1 mark. So friends, we have learnt about carbon compounds in this session. Why is carbon forming all these compounds? What is the property? It is catenation. Okay. So you should be able to understand each and every concepts from this chapter because carbon is found each and everywhere. If you will look at a living organism, it is made up of carbon, okay? So mostly living beings are made up of carbons, and we have many reactions going on, fuel combustion, we have the synthesis of food in the plant bodies, we have the respiration going on, utilization of that food. All of these things are about carbon compounds only. So this chapter holds very much weightage in your future studies as well. Okay. So we have completed the revision kind of thing in this video session using the questions that we have brought for you. I hope this session was helpful to you and it will help you gain more marks in your examination and ace your preparations that you are doing for the upcoming examination. Thank you for the attention.